All right, the first thing you want to do is look at the relationship between the angle and the second side. You'll notice that if this is our angle, which is A, then side A will be second side. And notice that it is larger than side 1. So because it is greater than side 1, this is actually the case where we're going to get exactly one answer. It's a congruence relationship, and the reason we know that is because that second side will not swing and form a second triangle. So we can just solve this like any sine law of sines problem. The sine of 47 is to 20, as the sine of C is to 12. When we cross multiply, we get something that looks like this. When we divide both sides by 20, we get the sine of 47 is to 12 over 20. And the sine of C comes out to be a decimal approximation. Let me calculate that. Approximately 0.4388. So if we do the inverse of that, so if we have the ratio and want the angle, we then can calculate this, and angle C approximates at, so second sine of that value, at about 26.03 degrees. So I've obtained now angle C. So this is at 26.03. I can actually also get angle B. Its value would be 180 minus the 47 minus the 26.03. And angle B would come out to be about 106.97. I have all of the information. I have A and C. The only thing I'm missing is B. So with knowing that this is 106.97, I can solve for B. The sine of 106.97 is to B, as the sine of 47 is to 20. And again, through a little cross multiplying here, we obtain this relationship. Divide both sides, we get the sine of 106.97 times 20 divided by the sine of 47. And again, we get B approximately at the value of 26.16. Now, one thing I want to show you, just to make sure that this kind of makes sense to you, B is the largest angle, and so the side opposite should be the biggest of the three, which it is. The second biggest angle is 47. It's across from the 20. And the smallest angle is 26, which is across from the 12. So that should work out there. But I've found now all three angles and all three sides. The problem has been solved.